temperature measurement is something that we are all familiar with in some form or the other. For most of us, the first time we encounter thermometer is in childhood when we get a fever and our parents put a thermometer inside our mouth. This thermometer, also called a mercury thermometer, contains liquid mercury and it expands in proportion to the change in temperature. There are also other liquid thermometers. For example, there is the alcohol thermometer, which is able to measure a much lower temperature range compared to mercury thermometers. But an alcohol thermometer, the alcohol inside it freezing. But in the end, both of these thermometers are using the expansion and contraction of a liquid due to a change in temperature for temperature measurement. When Celsius defined the Celsius scale, he took two phenomena which were very convenient for us, the freezing point of water and the boiling point of water, as two separate points on a scale. And he divided that scale into 100 equal parts. But ask yourself this, we use Celsius and we use the 2 points 0 degrees Celsius and 100 degrees Celsius because we are encountering water a lot in our daily life and it is something that is necessary for our survival. What would happen if you were an alien living on a planet where instead of water, we were using mercury? Mercury has a very different point for freezing and a point for boiling. So we would come up with a different scale. The other problem in this case is that different liquids will expand at different rates. For the same change in temperature, the same amount of mercury and water will expand at very different amounts. So these scales that use liquids for measuring the expansion and contraction due to change in temperature are relative scales. They are not absolute in the sense that they vary according to our convenience. Can we devise a temperature scale which is independent of the individual behavior of materials? Yes, we can. And that is where gas thermometers come into the picture. And the reason we can use gas thermometers much better for more precise measurements compared to liquid thermometers is at low pressures, all gases will expand and contract by the same amount. So this becomes an absolute scale rather than a relative scale. In addition, gas also behaves in certain specific ways. Let's review what these are. For example, a scientist named Boyle discovered that the relationship between pressure and volume for any gas remains constant if the temperature is kept constant. So what he found is that the product of P multiplied by V, where P is the pressure of the gas and V is the volume of the gas, will be a constant if temperature is kept constant. So this law is what we know as Boyle's law. Another scientist named Charles discovered that the ratio of volume to temperature, so the ratio of volume to temperature for any gas remains a constant as long as the pressure is constant. So what we are discovering is that if we keep the temperature constant, the product of pressure and volume remains the same. And if we keep pressure constant, the ratio of volume and temperature remain the same. We can integrate both of these laws into a single law. We can say that this ratio, P multiplied by V divided by T, will be a constant as long as all the samples of gas that we are considering have the same number of molecules. So this gives us the ideal gas equation that says, so here is the ideal gas equation which says that PV by T is equal to mu R, where mu stands for the number of moles of the gas and R is the universal gas constant. We can also write this as PV is equal to mu times R times T. Now, why is this relationship so important to us? We have learned earlier that under identical conditions, equal volumes of gas which are at equal pressure will contain the same number of molecules. This means that the variation of the volume occupied by these gas molecules, if the other two terms are kept constant, depends only on temperature. As you keep on reducing the temperature, the occupied volume of these gases will reduce, and we have shown that For all types of gases, the occupied volume will go to zero at a particular temperature, which on the Celsius scale is equal to negative 273.15 degrees Celsius. And this temperature is an absolute quantity. You can take any gas, any type of gas, and if you cool it down to this temperature, it will occupy essentially zero volume. As a result, this is known as an absolute zero. 0 degree Celsius is the temperature at which water will freeze, but it is not the temperature at which anything else will freeze. So that is a quantity that is related to the properties of water. It is not universal. On the other hand, this temperature, negative 273.15 degrees Celsius, is applicable to all gases. All gases, when they reach this temperature, will come out of the gaseous and liquid states and occupy the least possible volume. This is why we call it the absolute scale of temperature, where we define negative 273.15 degrees Celsius as being equal to 0 Kelvin. Note that we are not saying 0 degree Kelvin, we are just saying 0 Kelvin because this is not a relative scale. It is not a matter of degree, it is an absolute scale. So we simply say 0 Kelvin and never 0 degrees Kelvin. You can go anywhere in the universe, and if you cool a gaseous material, any gas, to this temperature, to 0 Kelvin, you will see that it is occupying the minimum possible space. At this absolute thermodynamic temperature, the gas molecules or atoms will completely stop moving and attain their lowest energy state. So the property of gases gives us an effective way of measuring temperature, which is independent of the properties of the materials we are measuring temperature with.
Manorama Horizon. Learning made simple.